4-6, multiplying and dividing monomials. As you can see here in the top in the blue, we have 2 to the third power times 2 to the second power. 2 cubed times 2 squared. Again, we're not interested in being able to expand the 2 to the third power and the 2 to the second power and finding out what all those 2's multiply out to be. We're not interested in that. We want to work towards getting to the rule at the bottom of the board, which is going to make multiplying and dividing monomials a really easy thing to do. Almost like another trick that we learned in the last lesson. But first, we're actually going to write out 2 to the third power times 2 to the second power in expanded form. 2 to the third power is 2 times 2 times 2. And then 2 to the second power is 2 times 2. Now, you could multiply all those 2's together and get an answer, but it's relatively easy with the 2's. But what happens if those were 37's? I don't want to multiply 37 times itself 5 times. Not interested. What we can do is take the 2 to the third power and the 2 to the second power and rewrite that using a new exponent form. So our base is still 2 because all these 2's are being multiplied together. And now how many of them are there? We have 2 to the 1, 2, 3, 4, 5 power. 2 to the fifth power. So 2 to the third power times 2 to the second power is 2 to the fifth power. Did you notice anything else without having to write out this middle step? We don't need to, as long as you notice something about it. Did you notice anything? 2 to the third power times 2 to the second power, which is actually our rule at the bottom of the board. We have a to the mth power times a to the nth power. A is any number, it's a base, and it has to be the same number. M and n are exponents. They don't have to be the same number. In fact, since they're different letters, they're probably different numbers. But for the purposes of this, a is the base and m and n are exponents. We can actually rewrite this as a to the m plus n exponent. So above, 2 to the third power times 2 to the second power is equal to 2 to the 3 plus 2 power, which is actually 2 to the fifth power. This is what your work should look like. This is our little trick for the day in multiplying monomials. When you're multiplying monomials and the bases are the same, you keep the base and add the exponents. So let's do the example in the middle. We have 4b to the seventh power c to the eighth power times 6b to the fifth power c to the first power. We deal with the numbers first. 4 and 6 really have nothing in common, and they have an exponent of 1. So let's just multiply those together and take care of that like we have since you was wee little kids. 4 times 6 is 24. The first variable we encounter in the problem is a b. We have 7 of them in the left and 5 of them in the right. I'm going to put parentheses around them just to sort of simplify things, keep things separated. You're welcome to do this as well. The next variable we encounter is c. We have 8 c's. The exponent is 8 on the left. And we have 1 c on the right in our problem, because if there is no exponent, there's always a 1. Okay, and then to simplify this, the 24 does not change. The variable b is now going to be, instead of 7 plus 5, is going to be 12. And c, 8 plus 1 is 9. 24, b to the 12th, c to the 9th. This is multiplying monomials together. Over here in division problems, we're going to write them in expanded form. We have 2 to the fourth power divided by 2 to the second power. Now, you'll remember yesterday we wrote them like this in expanded form, and then you did what? You canceled things out. we canceled out a pair of 2's here and a pair of 2's here. So that left us with 2 to the second power. So 2 to the fourth power divided by 2 to the second power is 2 to the second power. Again, we have a rule. Did you notice anything as we simplified this expression? We have a to the m divided by a to the n. And our rule gives us a to the m divided by a to the n gives us a to the m minus n power. So if you have 2 to the fourth power divided by 2 to the second power, that can be rewritten as 2 to the 4 minus 2 power, which is 2 to the second power. This right here is what your work should look like. Your homework today is going to be page 178, 14 to 42, the evens.